Hey, how's it going? So we're talking about the product rule here. Sorry, actually the quotient rule. Let me zoom in a bit. It's going to be a little bit of a long one today. So here's the quotient rule. It says that if I've got a function q of x and it's equal to f of x over g of x, effectively meaning that it happens to be the quotient of two other functions, then q prime, or the derivative of it, happens to be the gf prime minus fg prime over g squared. Okay, and well, let's just do a quick proof of it. And what I'm going to do is I'm going to start out with, I'm going to do a very quick sort of rugged proof. Q, right? Let me. Q is the quotient of two functions, f and G. I'm not going to write a bunch of X's just to keep it sort of quick. I could write an X here, an X here, and an X here. But then throughout the whole thing, I'm just going to have a bunch of X's. So let's just pretend like these are all functions of X. And what I want to do here is I'm going to just quickly multiply by G on both sides. So I've got G, Q equals F. All right. And now if I take the derivative of f, we know that based on the product rule, which is what we learned a couple of days ago, the derivative of the product of two functions is the derivative of one times the other one not differentiated, plus the derivative of the one that we didn't differentiate times, right? And this would be the derivative of f, assuming that f is the product of two functions. Remembering that q was the quotient of two functions. Okay. Oops. And so there we have it. All right. Now, what I think I'll do here is I'll subtract a g prime q over to this side. So it turns out q prime g. So what I'm trying to do is I'm going to isolate now. Notice there's q prime here. And that's what I want to find because I want to know what is the derivative of q if q happens to be the product of two, or sorry, the quotient of two functions. Well, here I have the derivative of q. But now I just have to isolate it. So I'm going to subtract over. So this is equal to f prime minus g prime q. Okay. And now, don't forget that q, by the way, is f over g. So I'm going to go ahead and replace, which I'll go up here. So q prime g is f prime minus g prime times q. But remember, q is f over g, which is the original definition of q. It's the function of, it's the quotient of two functions. All right. And so now look at this, how this is going to go. So q prime g is equal to f prime minus g prime f over g. And now I'm going to see if I can get a common denominator. So I want to go ahead and subtract, or I want to go to do it. I want to get a common denominator here. So I'm going to multiply this by g over g, thus effectively getting my common denominator. So I get q prime g equals g f prime minus g prime f over g. Pretty exciting stuff. And now take this g and I'm going to divide it down over to this side, and I end up getting a g squared on the bottom. And so therefore q prime is equal to gf prime minus g prime f over g squared. And that's what we have here. If you look closely here, up there, that's what we have. Pretty exciting stuff. And so there is our proof. Now, the proof relied on the fact that we needed to know the derivative of a product of two functions first. So if you recall, we proved that a couple of days ago. And so there it is. Pretty exciting. So now let's go ahead and use this rule a few times. All right. We got a couple of practice questions that we can do. All right. So, excuse me. Let's start with, let me move this guy down. I like to have a full screen. Moving this guy down, and there. We'll put this guy here. We'll full screen it. Okay, so there's our product rule. Sorry, quotient rule. So I'm going to show you guys how I kind of do this, especially at the very beginning. I notify, what I kind of do here is instead of calling this, whoops, that's a G. Instead of calling this Q of X is equal to F of X over G of X, I call it N of X over D of X for numerator and denominator. Okay? And basically, if I now look at the formula here, the numerator is F, and so F prime, so then Q prime of X, again, that's supposed to be a Q, I'm writing G's, so is G of X, so in this case, that would be D of X, times the numerator differentiated minus the denominator the denominator, see, look at this, I'm getting myself confused here. This is the numerator times the denominator differentiated, okay, divided by the denominator squared. Okay, so it's dn prime minus nd prime. Oops. Without all the x's. And so, honestly, I actually write it like this. dn prime minus nd prime over d squared. Okay? My pen's getting all funny. nd prime. Because I writing down all the x's just gets in the way. Like, we all know that there's x's here, and these are functions of x. So this is sort of the quick and easy way of remembering it. So noting that that's the case, I go ahead and I assign n being 4x minus 1, and d is x squared plus 2. So therefore, n prime is 4, and d prime is 2x. And so now, just like the product rule, it's this times this, but instead of plus, it's a minus this times this. So it's n prime d minus n d prime. So I'm going to go ahead and write that down. All right, y prime, which is the derivative, so it's 4 times x squared minus 2 minus 4x minus 1 times 2x over x squared plus 1 quantity squared. All that whole thing is squared there, okay? So there's my derivative. Pretty easy to do this thing. All right, so let's try another one. I got a couple of questions here that take them up some space. All right, so let's do this one. Sorry, I'm just going to move this down. Okay. So here we go. I got y equals, this isn't big enough for you guys to see. Let's just make this bigger. There, this should be enough. Well, maybe one more. Okay. Who knows? I don't know. We'll see. All right, so let me move this around a little bit. All right, there we go. So, okay. Hey, look at this. I got the sum of two functions, one of which is a quotient rule, and one of which is a very simple one. So my final derivative, y prime, it's going to be, d squared. It's going to be n prime d minus d prime n. So I'm going to do all of that. Then it's going to be plus the derivative of 5x. And so I'm going to just have a 5 over here. So notice I've got a quotient rule plus just a regular standard issue sort of basic introductory level beginner's derivative. Okay. So I'm going to have to multiply that or add that in over there. Okay. So let me go ahead and perform my quotient rule, and that'll fill in into this area here. Okay. All of these guys are going to fill in into there. All right. Here we go. So I've got a numerator, and it is going to be x squared minus 3 to the 1/5. Okay. And then my denominator is going to be 2x to the third minus 3. And so therefore n prime is going to be 1/5 to the negative 4/5, and it's x squared minus 3 and 2x. This is the chain rule. Notice what I'm doing here. The chain rule. This guy goes here, that guy goes there, this guy gets rewritten, this guy, the 1/5 gets lowered by 1, okay, and then the 1/5 goes over to there, and then this guy gets rewritten and multiplied out to the end as a derivative of 2x. Now, d prime is going to be, well, 3 times 2 is 6x, and I'm going to lower that to a 2. And then I'm going to add or subtract 0, because remember the derivative of 3 is just 0. All right. So here's my n and n prime, my d and my d prime, right? Assuming we remember the chain rule and how to do the power rule here. This is all pretty cool. And now I just go and I fill all this stuff in. So n prime goes here, d goes there, n goes here, and d prime goes there. So let's go ahead and do that. I'll erase this stuff. And we'll go ahead and throw this stuff in here. So it's a 1/5 x squared minus 3 to the negative 4/5 times a 2x minus 3, 2x to the third minus 3, okay, minus a x squared minus 3 to the 1/5, x squared minus 3 to the 1/5 times, let me move this 5 over, plus 5, times the 6x squared. And then I divide the whole thing by 2x to the third minus 3, all of that squared. Well, it looks like a crazy thing here, but, oh, you know what I missed? I think I missed my 2x. See this little 2x? I forgot it right there. I'm going to have to shove that in there. I'll just throw it in there real tight. There we go. Okay. Don't forget that 2x. All right. So there, that's our derivative. And then yes, obviously, if you'd like, you can, simplify all this down a bit. If you have to take, for example, a second derivative or something like that. But for now, this is, the derivative. Okay, let's do another one here. There we go. I'm going to move this guy down. And here. Okay. So, determine dy dx at x equals 2 of 3x over 2x squared minus 4. Okay, so what's the idea here? Basically, we got to take a derivative and then evaluate it at 2. This is Leibniz notation. Here's the function in question. And so let's roll with this. I have to first find the derivative. This derivative is going to be, I'm going to say the numerator is 3x. The denominator is 2x squared minus 4. D prime and n prime are each as seen here in the thing. And so my derivative, dy dx, is going to be simply 3 times 2x squared minus 4 minus 3x times 4x over 2x squared minus 4 squared. And now, if I would like to evaluate this at 2, meaning dy dx at x equals 2 is going to be, obviously it's going to be this. Just going to slap in a 2. You know, maybe we would have wanted to simplify this first, actually, and then plug the 2 in. But honestly, doesn't really matter. As long as you're able to keep track of all these things. Whoops, that's supposed to be a 2. And I calculated this out beforehand. Apparently it's a 1.5 or 3 over 2 actually is. Hopefully I got that right. I only did it once, so it's a lot of numbers, you know. This is 0, 4 squared. 2 squared minus 4. So this whole term is 0. And maybe this is like 12. This is 12. 3 times 4 is 12 times another 4 is 48.